is not page 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, page 4. Okay, don't forget to count the first when you start. That is the reason when you start the operating system, usually it takes a little bit longer time. Especially Windows use a lot of initial loading to the memory to speed up in the middle of the process. Okay, so that is because of the initial, the page 4. Okay, then we can do the same thing for the bigger size of the page frame. I'm not going to mistake this time. Okay. So first 1, 2, 3, 4. 1, 2, 3, 4.
4.
Okay, so it's 1, 2, 3, 4, page 4. Okay, then this time 1 is here, so no page 4. 2 is here, no page 4. 5, no, so we can decide the victim page, the first thing, the 1. Okay, and the 1 is here, but the no 1, so this will be 1, and this will be page 4. 2, this will be victim, and 2. 3 is a victim. 4, page 4, and 5, page 4. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, page 4. So this one has the 4-page frame. This one has a 3-page frame. Based on the previous discussion, the more page frame, the better performance. Less page 4, but it's not. This is called the Biladi's anomaly. Sometimes more frame, more page 4. Why this kind of thing happen? Should be supposed to be like this one, but it's still up. Why?
Because of the repetition, which pages are used more frequently. If they are used in and out, but then it was already taken out, so you have to
First, we consider victim page as the oldest one. But oldest one does not mean the useless, right? Some of them will be used again, right? Which means it's kind of also pattern of your program. So, like for example, if you see the pattern of the page 1, 2, 3, 4, 1, 2, 3, 4. Is it really happen in the real program? Or not? Yes or no? Why? Loop. When you are doing the for loop, while loop, or the something loop, it's actually process almost the same. The instruction again. So, for example, let me go back to all the way. So all the way somewhere. Yes. So when you are doing the programming, like not this one. Last. Somewhere. Yes. So when you learn the programming first time, probably the instructor asks when you are doing any difference between this one and this one. This is the initialization of the array. Okay? IJ. So initialization. Any difference in terms of output? No, it's nothing different. So all of them will be 0. However, inner roof and outer roof are the difference. So first array is here, but the first array is inside. Which one will be used? Which one was recommended in your programming class? You don't care? The second one. Why? First reason is, if you consider the process structure, it's a heap and stack. Heap is used for what? Dynamic allocated the data, like this. Then this one actually does not have the data 0 and 0, 0, 1. Instead, it has the data 0. Data 0 has what? Reference to somewhere in your memory. Okay, then data 0, 1, 0, 2, 0, 3, and so on. Then data 2 has a reference somewhere. However, if you are coding like this one, every time you need to in and out, not sequentially. Okay, so that may cause the more page 4. Okay, comparing to the opposite way. In terms of output, no difference. It's like when I check the group, we have the group. So if I'm checking the first student of the group, then next and next. But if I'm checking the first the member of each group, like all the way, then all the way, it will take a longer time to find the location. Okay, so that may cause because their pattern of accessing. Let's keep here. Somewhere like this one. So mostly such a loop is repeated. So it may usually happen a lot. So depending on the management issue, it can cause a lot of the page fault. That's called the thrashing. Sometimes such a performance will be, CPU utilization performance will be drastically reduced sometimes. That is usually caused by the page fault. Okay, so to address that problem, we can group them, which is called the locality model. So we can actually check the memory map along the time. So you can see this is a time. So certain, if you slice this way, is the memory, the physical memory, the access the pages. Okay, at certain time, you can see this grouping. It's called the locality. So you can make the group to address unexpected, to reduce the unexpected page fault. You can group the similar pattern of the pages together. Okay, so that is called the working set model to address the problem of the belated. Okay, so you can consider such a working set model. But do I need to investigate each code and everything? Instead, it's based on the access pattern, like this one. So using the access pattern, you can make the working set model that will be work always together. Okay. So like 1, 2, 3, 4 will be work set model. 1, 2, 3, 4, 1, 2, 3, 4. So they will be loaded into the memory together. Okay. Then we can address the unexpected page and eventually address the problem of the belated anomaly. Question?
Yeah,
okay, so that is the first approach, the first in and out. Any other idea? Definitely first in moves just like any algorithm that is based on the first in, first out, or first come, first serve. It's a simple to implement. Okay, always a simple, and it's mostly works well. It's a fair, it's a reliable time, but it's not the optimized one. So we can. What is your idea to address the problem of the first in, first out? Any idea? When you decide the victim, see which one is used recently. You'd like to keep the recently used one. Okay? That is another idea. Also, ideal case is see the future. Which one will be used? Okay, if at this time, if 1 is used, you can keep in the memory. If 2 is used nearby, keep it. If not used, that will be the victim. So that is called optimal. So optimal algorithm is the best one. But problem? You cannot see the future. But nowadays, it may be possible. Estimation, like using statistics. Nowadays, even though we can predict the future, like the stock market, trading. And that's the problem of the data analytics, data mining, and machine learning to predict the something pattern by considering, because it's not arbitrary happen. It's a kind of, there is a pattern of accessing the page memory. So this is the way to optimize can be made. But practically, most used one is the see the past. It's the LRU algorithm, least recently used algorithm. Okay, so we will see this LRU algorithm, optimal algorithm, in the next class for the last class of the semester. Okay, any question? Okay, thank you, and see you next week. And as I mentioned, please address any issue on your grading on the campus, then before the final exam. Okay.